Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is out of boundary paths, and it is a medium level problem. So basically they say that we have been given an m cross n grid and in which we have been given an initial position. So a ball will be placed at this particular position, and in one move we can move the ball to any one of the adjacent cells. So any one adjacent cells are the four adjacent cells: up, bottom, left and right. Right. Now, what we have to do is we have to find out the total number of ways we can move the ball outside the boundary of the grid by applying at most max move times. Right. So max move number of moves are the maximum number of moves that are allowed to us, and in these number of moves we have to move the ball outside the boundary, and we have to find out the number of ways in which we can solve this particular problem. So let us see how we can solve this. I am going to try to solve this problem with dp. So let me define my dp states first. My dp states, I'm going to form a three-dimensional dp of I, j and k. So what is this I, j and k denoting? I is denoting the current row, and j is denoting the current column, and k is denoting the number of moves left. Right. So dp of I, j, k together are going to denote the best answer if I start from I comma j position and k moves are left. Right. So that means I have basically defined my dp states. Now for all values of I and j, if my k is equal to 0, what do you think will be the number of what do you think will be the answer? Right. So in this case the number of ways or the answer is 0. Right. Because if I am lying inside the grid and I have only one way remaining, 0 ways remaining, 0 number of moves, and I have only 0 number of moves remaining, that means I cannot possibly go out of the grid. Right. This is a very simple logic. Now let me just draw a grid. Right. Now let's say you are at some point here. You have only one move remaining. How many number of moves do you have, or how many number of ways do you have to move out of the grid? In this particular case, there is only one way, you can go upwards. If you are here and you have only one move remaining, how many number of ways are to go out of the grid? You have two ways, one from here and one from here. Now let's say you are here, right? Now we have to figure out how many number of ways are there to go out of the grid. So how can we do it? Let's say the number of moves that are left with us are 2. So one way is to go to this particular one, and then from one move we can go outside, or the other ways we can go to this particular one and then in one move we can go outside. Right. So you see, if I am here with 2 moves, when I come here I will be left with one move only. But that is a sub problem that I have already solved. I just discussed when I am here and I have one move left, what is the number of ways, right? But when I was here at this particular position, I with 2 moves I moved on to this particular position and asked the same question again. With one move, in how many ways I can go outside from here, right? So now you will be able to see what are the transition states, right? So let's say if I am at dp of I, j, k, what I will try to do is I will go into 4 directions. So let's say dp of x, y are the new x and y coordinates, and I am going to do k minus 1 because I have already consumed one move in going from I comma j to x comma y. Now I might have already figured out the answer of this particular thing, that is from xy with k minus 1 moves how many ways I can go outside. That is exactly what happened with me here. When I was at this particular cell, I was asking the number of ways to go outside in one move. When I was at this particular cell, I was asking the number of ways to go outside in 2 moves. But then what I did was I consumed one of the moves and moved here. Then I asked the same question again, number of ways to go outside in one move from this particular cell, which I already asked before and I might have already computed. Right. This is how the dp states are going to depend on each other. Now let me quickly write the helper function. So let's say I have my helper function with 3 values int I, int j and int k. right? Now what I'm going to do is, if dp of I j k is not equals to -1, that means this has already been computed. I'm just going to return dp of I j k. And also I have a base case. If k is equals to 0, that means I can just return from here, return 0, right? Because if there are no moves left, that definitely means that I am going to not make any progress from here. Now let's say I do something here and I get the new values x and y, right? So let's say I am doing something and inside my loop, right? So let me write it here, exploring 4 directions, right? So we are not discussing right now what I do here, but let's just say I do something here and I get the new coordinate as x comma y, right? So now with this x comma y, what I can try to do is, if this lies inside, let's say I have a function inside which is going to tell me whether this particular coordinate x comma y is lying inside the grid or not. If it lies inside the grid, what I'm going to do is dp of I j k is equals to dp of I j k plus dp of xy k minus 1, right? So this is one thing that I do. What happens if it lies outside? If it lies outside the grid, that means I have found out one possible way of going outside the grid. So what I'm going to do is I'm just going to increment dp of I j k, right? So this is exactly what you have to do. And before doing all of these operations, let me just initialize dp I j k is equal to 0, right? So because it was initially -1, I have to initialize it with 0. And at the end, I can just return dp of I j k, right? So this is how your recursive function or memorization function will work, right? So what I have basically done is, I first of all written the base case, and if k is equal to 0, that means I have no number of moves left. That means definitely I cannot make any progress towards going outside the grid. Now, if this dp of ijk is not equal to -1, that means I have already computed it. I'm just going to return the value of dp of ijk. Now, if dp of ijk, I have initialized it with 0 and I'm going through all the 4 possible directions, let that particular direction be x comma y. If this new coordinate x comma y lies inside my grid, then I'm going to set dp of ijk as dp of ijk plus dp of xy k minus 1, because xy is one of the adjacent cells of ij and I have consumed exactly one move to go to that particular cell, right? So that is why from k we have reduced to k minus 1. So let me just write it, helper of x comma y comma k minus 1. So if you are using recursive or the memorization function, we have to write helper here, right? Now if it lies outside the grid, that means I have basically found out one more method to go outside the grid. So that is why I increment this particular thing by 1. And at the end I can just run dp of ijk. Now let us just particularly discuss how we can explore these 4 directions. We are just going to do it very quickly. What we can do is, we can define dx and dy array. We use it many times in grid dfs and grid bfs. So we just give it 4 values. Let's say 0 0 -1 +1, and then here -1 +1 0 0. We have given it 4 values, right? And each of these positions, let's say this is I. So if we have the current coordinate, let's say x comma y, we can find the new position as x plus dx of I and y plus dy of I, right? Each of these 4 values of I from 0, 1, 2, 3 are going to give us one of the positions from up, down, left and right. So let us see how. Let's say x is increasing this way and y is increasing this way, right? Just for this particular sake question, right? So what we do here is, if we consider 0 position, we see y is getting decremented by 1. That means y moves one space to the left and x does not change. This means we are moving to the left. So let me write it here as well. We are moving to the left. If y increases by 1, that means dy of y is 1. We add 1 to y. So y moves here and x does not change. That means we have moved right. Now if x is getting decremented by 1 and y does not change, that means we move one space to the upwards. So this is right and up. Now the last one would be one space to the down, and this is going down. So we have discovered 4 positions: left, right, up and down, right? So that's how this basically works, and you can figure out all the 4 positions in a clean way. Now when I show you the code, it will be much more clear to you. So this is my final code. I have done the iterative way, and we'll explain, or we'll go through this particular code as well. Now what I've done is I have created a DP vector of size n cross m. The very first thing I want you to notice is it was actually m cross n, but I just changed it to n cross m for my convenience. So that is why we have n and m here, and then we have max move plus 1, right? Because we want max move also inside this particular array range. Now what I do is I created the dx and dy array. I've initialized the modular value that we needed in this particular problem. Now for the base case, for all dp of ij, I am setting 0 as 0, right? So dp of ij 0 is 0. This was the base case that we discussed here as well in the recursive function, that if k is equals to 0, we just have to return 0, right? Now this is the inside function. Basically this is going to tell me whether the coordinate x and y is inside my grid or not. This is very simple. If x is less than 0, or x is greater than or equals to n, or y is less than 0, or y is greater than or equals to m, I just have to return 0 because this is outside the grid coordinates, and then in any other case I have to return 1. Now I am starting my let's say we just ignore this particular 3 for loops, and as you can see I am initializing dp of ijk as 0, the exact same thing that I did here. So you see dp of ijk is 0. Now I am just going through all the 4 directions, starting a for loop starting from 0 till less than 4, and for all the values of d in this particular case I am finding the new coordinate nx as I plus dx of d and new y as j plus dy of d. So you see how clean and simple this particular dx and dy array makes my code look, right? So with this particular for loop I am exploring all the 4 directions. Now if this particular new x and new y position are inside my grid, I am just going to set my dp of ijk as dp of ijk plus dp of new x new y k minus 1, and obviously taking the modular value. Otherwise I'm just going to add 1 to this particular dp of ijk and taking the modular value. At the end I'm just going to return dp of start row start column, and since I have max move number of moves remaining, I'm just going to pass on that particular thing, right? Now let us discuss these for loops, particularly what they are trying to do. For these I and j for loops, they are just simple for loops, but we see that we have put the k for loop in the outermost position. Why is this so? Let's say I am if you carefully see at any code, even in this one or this one, right, for all values of k we are depending upon k minus 1. Now you might also argue that for let's say xy we are depending upon x minus 1y, right? So why can't we make a for loop with respect to x? You see that for the same xy we are depending upon x plus y, x plus 1y as well, right? So neither we can start from the beginning and go till the end, nor we can go from the back and come to the beginning for these values x and y. This is a pretty easy way to identify that this will definitely not work if we place x and y outside, because you see that the dependency is non-linear. For the same x we are depending upon x minus 1 and x plus 1 as well, right? So that means we need some other variable in this case in which the dependency is linear. This is the only thing that we have to think about while forming the iterative DP. In like the top to down approach in this recursive DP, you don't have to think all of these things, but when you do bottom up DP or iterative DP, you have to think about these things. Trust me, like for the first couple of questions, you solve these types of questions, you'll have to think about it, but later it will just come to you intuitively, right? Now the only third variable we had with us is k. For all value of k, we are only depending upon k minus 1. We are not depending upon k plus 1. So you see, this is the one variable in which we are depending in a linear fashion, right? We can compute 0 first, then compute 1 first on the basis of 0, then on the basis of 1 we can compute 2, then on the basis of 2 we can compute 3, and so on, right? So this is the only variable in which the dependency is linear. That is why I have created the k for loop at the outermost position. Right. So this is one way of looking at this particular problem with the iterative approach. If you don't want to think all of this, recursive approach will definitely work. It is as good as this particular approach, and you can take any one of the approaches you like. I just wanted to explain why we put this k for loop outside, right? So this was all about this particular video. Let me just quickly submit this and show you that this particular code works and the solution is absolutely correct. So you see, this basically passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. Don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.